Welcome to Spilling the Tea, the podcast where we dive deep into the cutting edge of confidential computing and AI. I'm Lisa Loud from Secret Network, and I'll be your co-host today. This is not your typical podcast. Here we explore the real tech that's shaping the next wave of Web3, from zero-knowledge proofs, trusted execution environments, to the frontier of privacy-preserving machine learning and AI. Today's guest brings serious firepower, but before we get into it, I'm joined by my brilliant co-host, blockchain strategist, AI thinker, and one of the sharpest voices in Web3, Zoe McFox from Fala Network. Zoe brings a unique blend of strategic insight and storytelling to the world of confidential computing and AI. At Fala, helping to shape decentralized infrastructure that powers the trustless, privacy-preserving applications. And she's always asking how we make these tools meaningful, accessible, and human. So without further ado, I'd love to introduce our guest for the day, Greg Osuri, CEO of Overclock Labs and founder of Akash Network. Welcome, Greg.
Thanks, Lisa.
We'd love to hear just how you got to this point. Greg, just introduce yourself and tell us what you're doing and how your journey has led you to here.
Well, prior to Akash, I founded a company called Angel Hack. Angel Hack is the largest hackathon accelerator in the world now. Over 200,000 developers spread across 50 cities at peak. We were responsible for creating the modern day hackathon, the format that we all see. Several companies launched at Angel Hack. The most popular one that was launched was Firebase. Firebase eventually became part of Google and now one of the most successful tools, primarily for hackathon goers, right? So that's where I got introduced to problems amongst developers at scale, right? So we're talking about the most common problem being, hey, I go build a tool at a hackathon, get quick validation. Now what? How do I actually build a product from the tool that includes reliability when it comes to delivering the solution? So the obvious trend was the cloud, and cloud had its own set of problems, primarily rooted in the fact that the builders need to decide between convenience or ease of use and scale. So scalability and convenience were not something that would go hand in hand, and that was a choice we didn't want to make. So founded Akash to solve that problem, really, or the precursor of Akash, and found passion towards this technology landscape called container infrastructure landscape in a world that was primarily VM-based landscape. We're talking about 2013. Made some contributions, which led me to be a contributor to Kubernetes ecosystem, to Docker. This is in 2013. This is even before Docker kind of was released. I was working on several container native infrastructure projects, and Docker came and changed quite a lot of things. Seemed very promising. It did lack scheduling and orchestration, so that's how I jumped on to Kubernetes, and fell in love with Kubernetes. Started focusing on Kubernetes quite a lot, and wrote some libraries that are still very popular. In the space, they're still very actively used by Kubernetes and Docker and the whole ecosystem. I've been trending number 4, number 5 on GitHub Golang projects, right? So I was the only human being, I think, in the list at that time. So with that deep passion for open source, the deep passion for solving scalability with convenience, led us to question some of the trends that seem to be disturbing, especially with the cloud. As cloud was getting more important, this is a time where we still had a lot of folks managing their infrastructure. Cloud was kind of coming up and taking a more center stage, right? It was very obvious that when, the amount of concentration that's that we're noticing in the cloud, where we had incumbents being disrupted by newcomers, incumbents being Rackspace of the world or the older infrastructure providers are being replaced by this new API driven model. It was so powerful that it's very obvious to see how much of value extraction that's happening between these folks. And also we could easily see the cost, so anyone that practiced cloud, and I was consulting for a few companies in San Francisco, mostly growth companies in Silicon Valley, and it was very, very obvious to see the costs eating up, right? So, you start off with a fairly op fairly optimistic
Yes.
expectation on cost being low because that's the model cloud provider, but eventually it's actually directly
Yes.
opposite. So, and also another disturbing trend was it was getting increasingly closed. So the world was moving towards more open source, especially infrastructure. We came away from these like closed databases to open databases. We came away from, closed infrastructure protocols such as hypervisor or VMware to like more open systems like Kubernetes and Docker. But cloud was again reversing the trend that was also very disturbing. And third point was cloud was eating up open source so much. A typical pattern, if you look at Amazon, it would take on a successful open source project and white label it and sell it as the service, right? That was disrupting quite a lot of business models for open source developers. So we wanted to solve for a lot of these issues, right? So, and that's really where we, started working on open cloud. Can we actually create an open source cloud? That was a foundation, and Cornell University back then did some work around the idea called a super cloud. Sorry, so in 2015, they proposed that look, if you can aggregate compute, from aggregate compute resources and have the control plane decoupled from the resource plane, can actually create a super cloud. That inspired us to create Akash, and this is right when Ethereum Frontier launched, and this is pre-smart contracts on Ethereum. We like Ethereum, started on Ethereum, then CryptoKitties launched, crashed Ethereum. Then we went about, kind of came to a conclusion that layer ones are not scalable, and this is 2015, 2016. It was true, and still are very challenging to scale. That's when we started looking into how do we create our own layer one and Cosmos and yada yada. So that's the origin story of how Akash came together.
Here we are with, definitely an OG, Greg, in the space. I mean, you're building this since almost 10 years, right? 2015 is when you guys started, or definitely started with Overclock. So it's amazing to have you here. Also, welcome from my side again. Thank you for the amazing intro, Lisa. And I think because our session, I mean, this is what combines also the three of us here in the room today, right? How to actually create decentralized compute power for a better good and to also monetize it for the users, right? Because we at Fala Network also provide a TE-based decentralized compute cloud, similar than Secret Network, of course, with different features. And Akash here also focused mainly on the decentralized GPU. So it's great to have us three in the room here and discuss how we also use these decentralized compute power for the better and to make AI more decentralized and better, right? This is also a main focus of the discussion today. And Greg, I would like to ask you, what are the areas that you focus on right now within Akash to actually make AI better? I know that you actually sat down also with Jill during East Denver at the Secret Network Hacker House. She had wrote a great article actually about the conversation. We can maybe link it afterwards here in the podcast as well. And you touched on 2 points. First of all, the GPU shortage and the energy supply, right? That AI is definitely a big topic for AI. So maybe you can expand a bit more on this, what you with Akash Network are, how you're tackling these challenges, and what maybe overall, what kind of challenges we are facing here as builders within the AI space.
Yeah, how much time do we have? So I think, so the cloud model, broke a few things. I mean, they definitely gave quite a lot of advantages, but also they broke a lot of things. One of the things that we don't notice is they broke energy. Hyperscalers, for example, are usually data centers with over 50 megawatt capacity. 50 megawatts is quite a lot. And US hasn't quite, or most of the West in general, hasn't quite upgraded our energy grid for a while. Right. So securing 50 megawatt capacity is extremely challenging. And why? Because you don't have too many energy sources that can produce that level of energy with the efficiency that you need. Right. So I mean, coal and LNG is, well, not sure they're the only really options right now, but not so great for environment. Then you have solar. Solar, the big challenge is the storage is very, very expensive, and batteries. And then generators are impossible to get. There's a 5-year, in the wait time to get a generator today, for reasons whatever. Um, Hydro is very location specific. We don't have too many hydro plants, and then all the innovations, and we can't build nuclear reactors fast enough. The last one we built took about 14 years. So there are literally no new power sources to scale the hyperscalers, because there's so many of them that were built over the last few years. And US has our grid only gained about 10% in the last 20 years in terms of energy. So we've been consistently, because there hasn't been a great demand for energy until now. So now we have multiple reasons. AI is getting more complex. So the bigger the models get, the more GPUs they need. That means the more energy someone would need. Right now, we're growing at around, we're doubling every 2 years in terms of energy we need as the models get bigger and bigger. This is looking at the data from GPT-3 to Grok 3, Grok 3 being the most advanced model in terms of size. And if you extrapolate and project it, so today we have the XAI data center in Memphis, which trained Grok 3 is sitting on about 150 megawatt capacity, which is fairly large, by the way. It's a very large data center. Not the largest, but definitely a very large data center. And that's going to double in 2 years. That's 300 megawatts, and double in two more years as 300, 600, and 1.2. So you can see in the next 6 years, only way you're going to power a training run is using a nuclear reactor, because nuclear reactor is the only one that can produce over or a gigawatt capacity. I mean, at least now. I mean, you can have very large solar panels, but it's not very practical. So you can see the trend. So that's from a training standpoint, but from an inference standpoint, which I believe is going to be much larger than training, as you start building more products, as AI gets more relevant into people's lives. From an inference standpoint, the energy needs right now are fairly low, because we don't have the inference demand as much as the training demand. But inference, if you extrapolate it, I think depending on what model you look at, there are different fairly large, fairly good estimators, all the way from the big guys, be it Gartners of the world, all the way to some more the niche, estimation models where you take acceleration into consideration. But even from a basic, very conservative approach, we took a midpoint. The midpoint says that by year 2040, we'll consume about 8% of global energy just to power. And that's a big chunk. 8% is a lot. And we're talking about the West, right? So most of the energy today is produced in the East, in China, really. China has about 8 terawatt installed capacity. US has about 2 terawatt installed capacity. So that could also mean significantly larger portion of America's or the Western sort of like energy needs. And where is this energy coming from? Europe is decimated in terms of their energy infrastructure. Europe does not have, maybe France is a little bit more promising, but most Europe has decommissioned the nuclear reactors and have spent quite a lot in making sure that they cannot meet the future, and they're buying gas right now from Russia, sadly. And if you look at US, we cannot upgrade our grid fast enough, because the grid is aging, right? It's been around for a little over 100 years. So we need to upgrade the transmission lines. Transmission is extremely inefficient. And we can't put new lines, because nobody wants a new line in the backyard, because that reduces your real estate value. So this is very, very challenging in the US. How do we really, even if we produce energy somewhere else, we can't even transmit the
Right.
energy. So there's quite a lot of investment right now. I mean, Stargate, obviously announced by the current administration. A big portion of that is to improve the energy infrastructure. So bottom line, I mean, I can go on into like different challenges, why nuclear and yada, yada, yada. But, in the interest of time, I want to keep it short. But the bottom line is we cannot meet the energy demand in next 6 years.
Right.
Yeah.
The only way to solve the problem is to distribute it. Now, is distributed training really, I mean, another step back. There's a way we can solve the energy problem is by burning coal or gas. That's the alternative, right? Really, it's the only alternative. In fact, the Memphis data center in XAI data center in Memphis is only deriving about 7 megawatts from the grid. The rest, like the 143 megawatts, comes from burning LNG, the gas. And we're talking about Elon Musk burning
Well, what
gas.
about wind? I'm just curious. I
And
see
that's
so
the
many
irony.
windmills now when you're driving through the country. Is wind a contender for being able to scale?
Wind is very location specific. The largest wind farm we have is in Des Moines, Iowa, which powers the Google data center, about 500 megawatt capacity. And wind is definitely the most promising, most cost efficient. It's got its own risk, but from a cost per kilowatt hour, I think wind costs about 2 cents a kilowatt hour. Wind is probably the best. There's a lot of experimentation happening with offshore wind projects now. That's about 6 years down the line, we can get them. But the challenge is, even if you produce wind, you
Right.
got to transmit the energy somehow,
Transmission.
right? So yes, wind is definitely
Right.
most promising. There's quite a lot of new windmill projects coming on the coasts, but transmission is a challenge because if you want to have a data center, you need to have it in a strategic location where you have good, bandwidth. That's another problem as well, and good water to cool. So there's a lot of challenges. You can argue that if there's an ocean close by, you can desalinate with cheap energy and whatnot. But data centers are very, very hard to build in terms of like the quality you need, right? The resources you need, because data centers are all based in Virginia. I mean, Virginia. That's why you have US East as Virginia. Virginia, Philadelphia is where most of the energy projects are happening right now. But bottom line is, like, if you can figure out how to do distributed training, I think that's a big winner. So there's a case to be made here. And that's why I'm hyper bullish on decentralized AI, because the innovations that's been happening over the last, let's say, 3 to 6 months in the distributed training is very promising. We saw what happened with Dialoco. Google DeepMind wrote a paper called Dialoco. Prime Intellect implemented a paper called, they took what Google researched and actually completed the code and called it Open Dialoco. The two new models, the big model they announced that they're actually training right now, a 32 billion parameter model. They have trained a 16 billion parameter model, I believe, last, which was successful. It's still in the GPT-3 stage. Just to give a comparison, today we have GPT-4, 5, right? 4.5. We're still in the GPT-3 era of decentralized or distributed training, but it's progressing very fast. And only limiting factor is the amount of compute you can throw at it. And how do we get the compute is through incentivization. So if you can create a viable incentive model, that's where crypto plays a big major role, where if you contribute compute, you somehow have rights in the future earnings of that model, right? So there's a lot of work happening in that space. There's a company called Paralis. There's a company that's working on monetization. There's a company called Bagel. Protocols that will be launched very soon. They're working on monetization as well. Noose research is extremely promising. Noose is a incredible team out of Stability AI. They really recently released a paper called Distro. Distro stands for Distributed Training Over the Internet. It's a heterogeneous model. That means it doesn't have to be H100s or A100s. You can actually have combination of compute, which is very promising. They have interesting verification mechanism as well to verify the correctness of contributions for the training run. So there's a lot of work happening that are very, very promising for distributed training. I would imagine in the next 3 months, you're going to see quite a lot. I mean, Jensen, in fact, launched their testnet as well. They have trained over 10,000 models. So there's a lot of work happening in the distributed training, and that, I think, is going to be a big savior for this energy crisis we have. I mean, talk to any investor. I've talked to some of the biggest investors behind the Stargate project. Everyone talks about energy now. It's like how people talked about GPUs about 2020 to now it's all about energy. So, and where does Akash or decentralized networks fit in the place? Is like, well, we facilitate the computation required for the training, right? So you have this obvious decentralized training layer, news research and Paralis and Bagels and all the world that power this layer, and you need compute and you need infrastructure, right? And I think that's where we're going to see decentralized AI really take off, because this is solving a problem that traditional AI couldn't figure out how to
You
solve.
touched on the security, the issue of security when you talked about securing the energy grid. Does the model in Akash, the decentralized architecture model, I understand how that improves the energy situation. Does it introduce any security vulnerabilities?
Yes, we are talking about having compute in a trust minimized environment, right? So there's always going to be challenges about, well, person who has access to the box can can be a bad actor, right? Can take advantage. So I think another important aspect of being able to run in a decentralized manner or even train is verification of that compute or verification of that mechanism. Well, there are two ways to go about it. One is to trust the hardware, and ensure that in a manner where there is no tampering of a execution of a program. That's where TEE comes into play. I mean, you both are experts in this space. Second way is using cryptographic encryption, right? So, or primitives. So, can we actually verify that a person said what they're doing in a Z case, and there's a whole lot of work happening in that verification space, which is very application specific, right? So using TEE, we can have a much quicker, much faster go to market. And with the trade-offs being you have to trust the hardware, which is not a terrible trade-off considering that hardware is made by NVIDIA or hardware is made by a fairly large player. Of course, you can have always the Israelis come in, like tamper with your hardware. Sure, there's that question about the pagers, but what's the intention? You're not hopefully doing anything that would drive into that situation. Bottom line is the trade-offs are acceptable in terms of achieving the broader goal, which is, can we actually have a more integral or a training run that has integrity, but relying on these secure enclaves. Akash, where we stand is we don't build that. We, of course, we provide the infrastructure. We work with partners like yourself to that specialize in that aspect of the world to help us to integrate with us, sort of thing. We focus on making sure the hardware. I mean, one of the things that we're doing right now is enabling these small modular data centers. So, because as long as you have real estate space that can install solar, I think you become a data center. The only way we're going to be able to solve this problem is to harvest energy across the globe, right? So, so if you have about 4,000 square foot of roof space, which most of Texas ranch homes do.
Yep.
I live in Texas now, from San Francisco, and you can actually run a good 35 kilowatt to 50 kilowatt data center in your home. Considering that,
currently?
What was that?
Do you do it currently when you have the space?
Oh, yeah, there's a spec out there called AEP60 for Akash. Happy to share the link. There's a whole spec on like what would it take to run. Oh, I'm building that data center at home now.
At your home. Perfect.
So it's 35. It's about 50 kilowatt install capacity. You need about 24 hours of storage, so you can do about 1.5 megawatt of energy of batteries. The big challenge right now is batteries were getting cheaper until the tariffs came in, because most of the components in the battery, which is like lithium, cobalt, and
Imported.
forgot the other one. Sorry, didn't sleep well. Lithium, cobalt, and nickel. which contribute about 60% of the battery cost. And that is getting very expensive now. That's why we got to liberate Greenland. Anyway, so rare earth minerals are extremely challenging to get. We don't know what the political situation is going to drive this cost, but I'm praying that they were coming down as people are discovering more lithium mines. Hopefully, they'll come down much cheaper because that'll make owning solar more practical. We also have a scenario with generators. For some reason, the lead time on a generator right now is about 5 years.
Wow.
Which is challenging because, I think there's something to say about smaller generators. Much easier to get their own larger generators now. So you have to consider LNG as your backup liquid, natural gas, or your diesel generators are very hard. So there is some amount. It's not straightforward to be fully fair and honest with you. Although we can get compute now, which is much easier. That was a big challenge about a year ago. We can get compute now, but getting the energy infrastructures is getting more and more challenging.
But you did summarize it nicely, right? I mean, to the intro question from my side, like how you tackle these challenges, you provide a decentralized GPU network, you facilitate decentralized GPU to make it more accessible. You mentioned amazing use cases, or that we can also look up that have built on Akash, or that were inspired by like the decentralized access. And on top, you have like the specific use case and even a specification that you said how to build actually energy areas at your own home on your roof. So I think these are definitely forward-thinking, very visionary approaches. And I think if we inspire more people and have builders also really use the existing space at home, it's definitely a way to go, right? Like the approach that if the community sees the opportunity, that we can overcome these challenges that you mentioned that maybe we will approach in the next 10, 15 years.
There's also another advantage when it comes to privacy, right? For example, you talked about like, hey, am I comfortable with privacy? I'm like, I'm not comfortable with privacy if it leaves my home. Anything that leaves my home, doesn't matter how secure the cloud or wherever I'm putting this data, I'm never comfortable. So if I want full AI, well, I'm talking about AI managing every aspect of my home, right? So I'm building a fairly large home where my mother-in-law and my family plans to come and live with us as they get older. And a big challenge in having a ranch home in Texas, which you have a lot of space, right, is we don't know where people are in the house and who's in the house, and we don't know if they fall, if they're okay, sort of thing. So every aspect of the house is managed by an AI that's local, DeepSeek, right? So all the sensors, be it infrared, and be it UV, be it sound, or whatever sensors we have to detect faults, to detect dangers, to detect every aspect of the home, security as a matter of fact. And I want agents to run everything. I mean, because every meeting should be recorded, every conversation should be recorded, every aspect of the home should be recorded, not shared publicly, recorded, analyzed, inferred locally, right? Because I don't want that information to leave my home because some privacy net. The only way to achieve that is to have a GPU cluster running. And to run a DeepSeek, you need an HGX cluster, about 8 GPUs, right? So that way you have sovereign local AI and if you follow the configuration, having little more boxes and putting those boxes on Akash can earn income for you because you're hosting, you're offering those boxes, and you can actually cover the cost in 3 years. We did the math and we shared the math online, 3 to 4 years.
One more question regarding, I mean, you mentioned the agents at home, but if you look into like more like a general tech stack, even for, let's say, web applications and so on, where do you think, in which areas, when we talk about agents, application, the GPU, the inference and so on, or even the grid at home, where do you think the verification based on TE or ZK or whatever verification method you want to use is most important? Like in which
verification is not needed when you have your own local clusters because you don't need to rely. Verification is important when you rely on a third party that you don't know, right? So if you're doing a training run, for example, right? So so the model that we're proposing, or Akash at home model, is have about 40 GPUs, right? 40 H200s. It'll cost you about $2 million. Use 8 H200s for your local AI, That means you're running your agents or whatnot. You don't need trust for that. Then rest 32, lease them out on Akash, right? You will recoup the investment in about 2 years. In fact, we can use DeFi rails to even fund the whole thing. So you don't need to put up upfront. There's a very exciting opportunity in energy I want to talk about a little bit in decentralized energy and DePINs in general. Um, and so we figured out a mechanism where you don't have to put a single penny up front and the whole thing will be financed, and you effectively get the hardware for free. So this way, these 32 other GPUs that you have access will be participating in a training run somewhere else, earning you income, right? So obviously you need secure enclaves there, you need verifiability there, because whoever is running the training run needs to know whether you're telling the truth or you having a cyber attack in general, right? So that's where we at a high level architecture. But when it talks to opportunities when it comes to earning, so if you look at the energy scenario again, we could keep going back to energy because it's quite a lot here. California has during daytime, about 6 hours, you have sunlight. California has quite a lot of solar panels. California produces California consumption is net negative during the day. That means it produces way more energy than it consumes. Because of 6 hours of sunlight and all that is producing. Whereas there is a moment that there are probably a few seconds of switch off when the sun comes down. They turn on all the other generators because energy is real time. There's no storage. We don't think about this infrastructure a lot. This is real time. So all the energy that you're having in your home is coming because there's a nuclear plant that's producing energy in real time, right? So there is a switch off time in this like few seconds that they turn on all the nuclear reactors and all the coal plants, whatever they need to. And if you can sell energy during this switch off time, you get the most bang for your buck. So you produce energy at home, you got to sell it back to the grid, right? Grid pays you next to nothing because they don't need energy during the day. It's too much excess. So your market rates is fairly low. But if you can sell the energy during that switch off time, it's crazy how much you can make. So there's a DePIN network called Daylight Energy, which is recently announced funding from Andreessen Horowitz. They're working on this. They're working on a mechanism where they'll finance the whole energy infrastructure for you. And you just essentially sign a paper. And that is a foundation for Akash and a lot of decentralized compute, I would imagine. So if you have energy that's producing, if you're, I don't know, just hypothetically speaking, if you're making about 10 cents a kilowatt hour, using Akash, you're literally selling energy for 3 cents a kilowatt hour. Oh, sorry, for $1.50 kilowatt hour because you're adding GPUs on top of it, right? So think of GPUs as a wrapper on energy in terms of income, right?
The layer 2,
anyway, so
it's energy layer 2.
Energy is layer 2. End of the day is, it's thermodynamics. End of the day, energy is the most fundamental unit. And how do we add a premium on top of energy if you want to sell? Add a GPU on top of it, because that's what you're selling. So there's quite a lot of excitement in DePIN, I think, that that is solving energy, solving bandwidth crisis, and I can go on, but it's very, very exciting time right now to be in decentralized AI and decentralized infrastructure in general.
That brings up a really interesting question. Do you think decentralized compute is ready for mainstream applications in AI? Well, not that there are that many AI applications in mainstream yet. It's mostly, we're getting there. But do you think that the decentralized compute that Akash provides is ready for actual usage?
Oh yeah, people are using for actual usage, right? There are companies, most of the companies that use Akash are folks that are optimizing their unit economics in the sense, well, when you venture back, you don't need to optimize your unit economics in the early days. You'll eventually have to when you start building a real business. So when you're having a real business, you got to make sure that your supply is lower than your income to profit. So a lot of companies that use Akash are in this like growth stage and they're growing really fast because I know the demand they're putting on the network. But the question about Well, so during the 2023 crisis, the demand on Akash was significantly high, right? Because you couldn't get GPUs, and Akash and some of the decentralized networks were the only places you can get GPUs, Akash being the main one. Now the supply has increased. Like NVIDIA started producing, produced about 2 million H100s last year compared to about 500,000 H100s in 2023. So definitely the amount of H100s, the supply has increased quite a bit. It's still not very well distributed again because the big challenge to put this GPUs is no longer how many GPUs you can get, but how much energy you can get. Remember, so most of the times you'll get neoclouds, we call them. Neoclouds are these small cloud companies that were primarily funded by NVIDIA. Biggest neocloud would be CoreWeave, which is obviously a very large success story. But NVIDIA started funding anyone that has energy, that can get energy. Anyone. You can get 10 megawatts, you put a data center there, NVIDIA will give you the chips. So we have a lot of these neoclouds, hundreds of them literally now, that all don't know what to do with their compute because they're supply, but they haven't aggregated demand. So there's a big sort of like need for aggregating demand right now, primarily driven through this like hyper-saturated supply chain on the back end. I think that's where decentralized cloud plays an incredible, or decentralized marketplace in general play incredible value. And I think when the training starts, when we start producing state-of-the-art models, fortunately, the training landscape has evolved from getting larger and larger LLMs to more expert models now, using mixture of experts, right? So we don't need to go produce a massive, a trillion parameter model, but rather a 70 billion parameter model that has expertise in a certain area outperforms a large model that is more general purpose, right? So I think from a mainstream adoption standpoint, today we have coding, software development as mainstream as it is for AI, right? So I no longer use non-AI based tools to write code. In fact, as CEO, I haven't been writing code quite as much as I used to back in the day, but now I am writing code as much as I can because AI is assisting me. And someone like me who has domain expertise and understands the problem space, it's a godsend because now you can interact and you can iterate the problem with AI. And my ability to write a spec is much better now. I can think more clearly, and for folks that can write a clear spec, I think using vibe coding, or I personally don't like the term vibe coding, but for all intents and purposes, let's use it. The vibe coding is a boon because you can produce so much output, especially if you're a senior programmer that understands, has a lot of experience in programming, and you understand the constraints you need and the design patterns you need. And for someone like me, it is incredible. And they say AI makes smarter people smarter and dumb people dumber. I think that's very, very true. Of course, if you're vibe coding without knowing what you're doing, it can be challenging. Yeah.
So yeah, definitely an adoption in the mainstream use, but to decentralize AI, I think there's quite a way to go, right? And to make it, to give it the best impact that we also create in the Web3 space regarding the infrastructure. Maybe as a closing question, Greg, to you, best case scenario, let's think optimistic. What can we all do? We discussed some scenarios, what you guys do at Akash, but what can an individual and also a company, Web2 or Web3, do to actually work for good AI? And I quote you, before it burns down the planet, right? Like, what can we all do to avoid this scenario? And if we all start to work on this, whatever you suggest us now to do, where would we be in the next 5 years, if that's a good time frame? Like, how can we really create this best case scenario?
So best case scenario, in my opinion, would be AI needs to be if you think AI is going to be the most transformative technology in our generation, which I believe it is, I believe 10,000, about 100 years from now, people will look back at this era and if you think about, the first thing to think about is this is the era that defined human acceleration. I think we're going to have a exponential growth, and humans are not good at visualizing exponential growth. We went like what happened in the internet. Nobody could really fathom as to what kind of growth we're looking at. I think that's going to be a bigger accelerant, right? So the when we have this future that's so transformative, we don't want this future to have the same amount of risks that the last accelerant happened. So a big risk today is concentration or centralization, right? I mean, don't like to use this broad word, concentration, centralization, but really, if you break it down, we only have 20 hyperscalers or 20, 30 hyperscalers in the US, right? We know those locations. So tomorrow, when there is a geopolitical situation that's not great, these 20 regions can be easily compromised with advanced weaponry. So if you have to rely on AI, then internet was created in the 60s to combat the centralization of data centers, right? Like, because we had large mainframes and people were like, this is not good, because one mainframe gets attacked, we're done. And same thing is happening with AI. We have 20 hyperscalers. It's not good because they get attacked, we're done. So the best thing you can do is, number one, like, distribute AI as much as possible. AI should be with everyone, not with anyone, right? Any single one. So, and that also solves the energy crisis. I mean, it's not only that, we if you want to reduce the energy grid, like in Memphis right now, there is increased amount of respiratory incidents, conditions right now in Memphis, southern Memphis. There's a lawsuit I don't know whether it's going to be filed, but Southern Law Poverty Center, this is all public knowledge, by the way, you can Google. There's a looming lawsuit against XAI because people are getting sick. People are dying right now because of AI training, right? And that is not okay. And from the looks of it, one of those, I don't want to name who it is, but one of the large investors I spoke to has massive ambitions to deploy enormous amounts of capital to build out power plants. And these are coal power plants. 2025, we're talking about deploying coal. Now, it doesn't matter what side of the environmental agenda you're on, coal is bad. It's pollutant. It pollutes air. Burning gas is bad. It pollutes air. I don't like pollution, right? That will cause all kinds of issues. Now, that's the direction we're going right now, right? And and it's really sad. And I'm afraid with the current administration, which is being pro-acceleration, pro-innovation, which is great, but I'm afraid that they're going to overlook some of these important aspects of health that is going to impact our kids. And that's I'm really concerned about as a father. And the way we combat that is obviously accelerate how we can solve these without concentration but distribution. How can we really distribute resources and pay attention to some of these innovations and make sure that these innovations have enough attention people are getting, and make sure that they're known, right? So we're doing our part in making sure that you can train in a decentralized manner. We're going to make it easy for people to participate, right? As a decentralized hub, we are Akash, decentralized AI hub. We are, and I want more people to pay attention to this issue. I think that's one thing. And from an optimistic scenario, the same actually better. Like, instead of having 20 data centers, how about 10,000 data centers where it's impossible for an adversary to compromise our AI infrastructure in the future? Right? I mean, that's what you want. One data center goes down, who cares? We have 10,000 of them, even more, right? So, and I don't want identity of these people, because identity can be compromised, right? So unidentifiable, trust minimized data centers that is just contributing to the training run, contributing to the inference run, but not necessarily exposing who they are, and you don't need to. So that's one of the areas we can achieve using TEs and trust minimized approaches. So the more anonymous, the more distributed the infrastructure is, the more likely we're going to survive as humans, both in terms of environmentalism. I don't like to use it because that's politically enrailed, right? I mean, not talking about like reducing carbons and whatnot. I'm talking about real pollution, like bad air. Doesn't matter what side of the political spectrum. Bad air is bad air. or bad water, right? So let's avoid these large deployments to more nimble, more distributed deployments. That's really the optimistic future, I would say.
Perfect. No, that's beautiful because in the previous sessions, thank you for really sharing the deep knowledge on the energy level. We have mainly talked about why AI is important to be verified, like the centralization. It's a black box. We don't know what actually is being executed, right? But today, I think we really explored why decentralized compute is so important. Not only the verification that we get through it, but the decentralization to actually overcome these risks and challenges that we might face in the next year. So I think it was a very good insight how the important to really look or highlight the importance of decentralized compute, including verification or decentralized compute and CPU or GPU overall for the AI space. So thank you very much, Greg. I think it was
I
great
learned.
insights.
Yeah, so you cannot have decentralized compute without
Right.
verification, right? That's
Yep.
it's such a like core component of coexistence.
Yep.
That because the moment you have anonymous people sharing, you need to verify.
Right.
There's no way in hell. So I think the decentralized stack is what I really want to focus on.
Yep.
It's so critical. The training algorithms, the verification algorithms, the infrastructure algorithms on networks, and so on and so forth. And the infrastructure includes compute, energy, bandwidth. There's a lot of components to this infrastructure as well. So I think overall, the entire stack is what's the most important and the biggest savior that we all need.
Right. Thank you, Greg. Very insightful. I learned a lot. I'm sure our audience will appreciate the insights that you shared, and we really appreciate your coming and sharing your time with us. If people want to know more about Akash or want to use decentralized computing, would you like to tell them where to go?
Yeah, Akash.network is a hub. You can find all the links, all the socials. I'm fairly active on Twitter. Greg Osuri is my handle. Hit me up if you have any questions or if you want to talk further. And we'll be releasing a paper on all the energy discussion that we just had very soon. We're looking at from like a compute and a feasibility, and we'll go more into details as to what are these algorithms.
Oh, we'd love to.
How are they
We'd love to link the paper before we publish. We'd like to link it in the podcast.
It's going to take a while, and I'm writing it,
So we'll see. Okay. All right, great. Thank you so much for being with us. Thank you, Zoe, for co-hosting an awesome conversation, and we will see you on the next episode. Thank you, everyone.
Thanks,
Awesome.
Lisa.
Thank you.
Thanks, Greg. See you soon.